All right, let's dive right in. Today, we're talking about a piece of technology that's quickly becoming one of the most important parts of the entire AI stack. Seriously, it's the key to taking AI from a fun toy to a tool you can actually rely on, especially for business. We are talking about vector databases. So you've probably been there, right? You're using some super advanced AI, a model that cost millions to train, and you ask it a simple question about your own company's data, and it just gives you nonsense. It makes you wonder, why do these incredibly powerful AIs sometimes act so, well, dumb? Well, it usually boils down to three big problems. First, the AI hallucinates. It just makes stuff up and says it with total confidence. Second, it has what you could call conversational amnesia. It forgets what you told it 5 minutes ago. And maybe the biggest problem of all, especially for businesses, is that it knows nothing about your private data. It's locked out. So what's the fix? Well, you have to give the AI the one thing it's missing: a good, reliable, long-term memory. A second brain, if you will, that's designed to hold all that specialized knowledge. And that, right there, is exactly what a vector database does. Okay, so let's get into our first section here, AI's memory problem. We're going to look at how we can actually ground these models in reality. And the magic trick here is a technique called Retrieval-Augmented Generation. Everyone just calls it RAG for short. This is the bridge that connects the AI to the world of facts. And you know what? The way it works is actually pretty simple. First, you ingest your data, all of it, your PDFs, your company wikis, whatever. It all gets converted into a special number format called a vector. Then, when someone asks a question like, hey, what was our Q3 revenue for Project X? The system retrieves only the most relevant snippets of text from that database. And here's the crucial part. It generates an answer by handing that text to the AI and saying, answer the question, but you are only allowed to use the information I just gave you. And just like that, you stop the AI from making things up.
All right, section 2, the mathematics of meaning. That retrieval step sounds amazing, but it begs a pretty big question, right? How in the world does a computer know what relevant even means? This is where we get to the real magic behind all of this, the art of turning words and even images into pure numbers.
This right here is the big aha moment. An AI model can take any piece of data, a word, a sentence, a picture, and turn it into a long list of numbers. That list is called a vector embedding. The easiest way to think about it is like a coordinate on a giant map, a map of meaning. On this map, things that mean similar things are physically close to each other. So canine, dog, and wolf are all clustered together in one neighborhood, while something like automobile is way over on the other side of the map. It's simple. Distance equals similarity. And this little chart just shows you why that is so powerful. Think about old-school keyword search. You search for the word automobile, and you only get back documents that have that exact word. But semantic search, which is powered by these vectors, understands the idea. So when you search for automobile, it finds car, sedan, even Ford, because it knows they all live in that same neighborhood on our map of meaning. It's a total game changer.
And this is really the bottom line. We're moving away from just matching words to actually understanding concepts. The system can find what you mean, not just what you typed. It's a huge leap forward. Okay, section 3, searching at ludicrous speed. So, we've got our amazing map of meaning, but there's a catch. If you have billions of data points, checking every single one to find the closest match would take forever. This is a famous problem in computer science called the curse of dimensionality. But, of course, vector databases have a really clever way around it. Instead of doing an exact, perfect search, which is kind of like driving to every single house in a city to find one address, these databases use a shortcut called Approximate Nearest Neighbor, or ANN. I love this analogy. Think of it like a highway system with multiple levels. You start on the top level express lane to get across the city really fast, then you drop down to the local roads to find the right neighborhood. The result? You get there almost instantly. Now, you might sacrifice a tiny bit of perfection. Maybe you get a 99% perfect result instead of 100%, but the jump in speed is just massive. We're talking about a search going from minutes to milliseconds. So now that we've got the what and the how down, let's get practical. Let's look at the actual tools out there. Who are the big players in the vector database world, and what makes them different?
When you look at the landscape, it really breaks down into two main flavors. You've got your native vector databases. These are tools built from scratch for just this one job. And then you have integrated solutions, where vector search is basically added as a feature to a database you might already be using for other things.
This table tells a really interesting story. Let's just walk through it. First, look at that type row. You've got managed services that you just pay for, and then you have open source options you can run yourself. Now check out ease of use. Pinecone gets 5 stars because it's designed to be dead simple for developers. It's all about getting to market fast. But then look over at scale focus for a tool like Milvus. You see massive. It's an open source beast built to handle over 1 billion vectors, but all that power means it's more complex to manage. And then you have a fascinating option like Postgres with its pgvector extension. It gets a high ease of use score, not because it's the absolute best at vector search, but because it's integrated. Teams can just use the database they already know and love, which is a huge advantage.
And that leads us to a really important prediction that people are making. It's being called the Postgresification of vector search. The basic idea is that, for most people, maybe even 80% of all use cases, the convenience of just using the database you already have, like Postgres, is going to be good enough. It's going to win. For that other 20%, the giant companies working at incredible scale, they'll still need the raw power and cost savings of a specialized, dedicated engine.
So, Section 5, choosing your AI memory. With all these choices, the million-dollar question is, which one is right for your project? Let's try to boil this down into some simple, actionable advice.
All right, first up, the keep it simple strategy. If your team is already using PostgreSQL and you don't think you're going to have more than, say, 50 million vectors anytime soon, then just using pgvector is a fantastic choice. You get all this new power without having to manage a whole new system.
Next, the we need to move fast strategy. If your absolute top priority is getting your product out the door and you don't want to deal with managing servers and infrastructure, then a managed service like Pinecone is probably your best bet. It lets your team focus on building the actual app, not on being database administrators.
And finally, there's the hyperscale strategy. If you are operating in the big leagues, we're talking hundreds of millions, maybe billions of vectors, and your main goal is getting the absolute best performance at the lowest possible cost, that's when you turn to a specialized open-source powerhouse like Milvus or Qdrant.
So what's next? Where is all this going? By 2025, you can pretty much expect hybrid search, that's a mix of semantic and old-school keyword search, to be the standard for any serious system. By 2026, things get even cooler. Multimodal search will be common. Imagine searching your company's video archive just by typing a question. And down the road, new kinds of computer chips are going to make all of this way, way faster and cheaper for everybody.
And this quote really brings it all home. At the end of the day, the big AI models themselves are going to become commodities that anyone can use. Your real competitive advantage, your moat, is going to be your unique data and, just as importantly, the vector infrastructure that lets you actually use that data in an intelligent way.
And that really is the final thought here. This isn't some far-off future tech. It's happening right now, and it's changing everything about how we find and use information. So the only real question left is the one on the screen. How are you going to use this to unlock all of that meaning that's just sitting there hidden inside your data?